All right, Calculus, welcome to Limits Quiz Review video. We've gone over these questions in class. I just want to provide you a quick video here with the answers. Answer number one is as follows. All you're doing is factor and cancel out, and then when everything's canceled, especially the x minus 4, you can plug it in. Here, guys, if the highest power is on the bottom, the limit as x goes to infinity is always 0. Pause this at any time. This is going to kind of be quick. Remember, we always multiply top and bottom by the conjugates of the root we're trying to get rid of. All right, we've practiced that a bunch. The x minus 5s will cancel. Then you can plug 5 in. Root 9 is 3. 3 plus 3 gives you 6. Guys, I can plug 2 in. I don't get 0 in the denominator, so I can just simply plug it in right away, get 9 over 2. Next one right here, when you have the same power, the highest power on top and the bottom, then your limit as x goes to infinity, same thing as your horizontal asymptote, is just the ratio of the leading coefficients there. 3 over negative 4, negative 3/4. On 6, guys, if I give you a piecewise function, just simply, especially the limit as x goes to 3, kind of my transition point there, plug 3 into that first equation, plug 3 into the second equation. If you get the same answer, then that's simply the limit. If you do not get the same answer, then the limit does not exist. All right? Pretty much every question I go over today, the same ones like I talked about in class, are the ones to hint, hint, wink, wink, know well. Guys, top and bottom, make sure you combine first this this fraction up there, okay? So when we get that, when we subtract those two, we get a negative x. Numerator, they cancel. And again, plug 0 in for x, you get negative 1 over 27. On 8, as x goes to negative 1 from the right side, that means it's on the right of negative 1, so x is greater than negative 1. So I'm using that third equation. Plug negative 1 in for x, it's going to be negative 6. Guys, on 9, the highest power is on top, so there's no horizontal asymptote. That means the limit of f of x as x goes to infinity is infinity. It's unbounded. Guys, as x goes to infinity, that 6 is going to be so small, so it's basically just going to be 9x squared in the square root, which is 3x, same power, so 5 over 3 would be your limit as x goes to infinity. 11, just multiply top and bottom by root x plus h. So the square root of x plus h plus root x. Anyway, a lot of canceling. There's your answer. On 11, this is a sum of perfect cubes, so that's how that factors. X plus 3 is canceled. Plug negative 3 in for x. You get 27. All right, here on the next page, yes, some of us struggled with factoring a little bit. Guess and check method. Only way to get 2x squared is to have 2x and x. Only way to get 5 is to have 5 and 1. One of them's negative, one of them's positive. Negative 5x plus 2x gives you negative 3x is what you want. How you get 4, 2 and 2, 4 and 1. If we try 4 and 1, the only way to get 3 is to have 3 and 1. 3x, 4x, folks. X plus 1 equals 0, x equals negative 1 is a discontinuous point. Set this equal to 0, x equals negative 3/4, a discontinuous point. That's a vertical asymptote because it didn't get canceled. This is a removable discontinuity or hole because it did get canceled. Guys, plug 2 in there, and there. You get the same answer everywhere, so it is totally continuous. If I want the same type of thing, guys, I need to plug 5 in for x, I get 3. I need this to be 3 also for it to be totally continuous. So I want this to be equal to 3. Well, I know that x is going to be 5, so 5 times k, 5k minus 3, set that equal to 3. You get k is 6 over 5. All right. Guys, on the next page, really just know, especially like on the back page, so the limit as x goes towards negative 2, it's going towards negative 2 there, it's going towards negative infinity. The limit as x goes towards negative 1 from the left, there's negative 1 from the left, it's going towards negative 1. And then the limit as x goes to 2, from the left, from the right, it's going towards a y value of 2. There's a hole there, but it's still approaching that. All right. On the next page, use the graph to find the limit as x goes to 2. As x goes towards 2, that y value is not... Yeah, it is 4. I'm sorry. F of 2 is 3, but as x goes towards 2, you have a hole at 4. Guys, plug 2 in for x. You get 5, you get 6. 5 does not equal 6. The limit does not exist. You have the same highest power, so it's the ratio of the leading coefficients. It's simply 2/3. Factor another sum of two perfect cubes, x plus 2, and then this. X plus 2's cancel, leaving you with, because x is going towards -2, 4 plus 4 plus 4, 1 over 12. All right, so really, not too many more. I did circle these ones right here. Again, multiply time divided by the conjugate root x plus 4 in the the square root plus 2. The 4's will cancel, the x's will cancel there. So then we'll cancel them right here actually. Plug 0 in for x, you get 1 over 4. Where is f of x not continuous? So first off, at that vertical asymptote, set this equal to 0. You have a vertical asymptote at x equals -4. Then plug in those transition points right there. So plug 5 in, you get a 1/9. Anytime x is greater than 5, it's always a half. 1/9 does not equal a half, so you have another discontinuity at x equals 5, all right, because you don't get the same y value. So you have two discontinuous points, x equals -4, x equals 5. And guys, on this one, nothing's going to cancel, so simply set the denominator equal to 0. You have discontinuous points because you have two vertical asymptotes. X squared minus 7 equals 0, x squared equals 7, plus or minus root 7. All right, and I believe that's pretty much it until the very last page. Hint, hint, wink, wink. You can definitely... Now, I did say actually on this page, page 11, know how to do those 3 through 9. Hint, hint, wink, wink. All right, so those are ones you're going to practice on your own. And then lastly, the last two pages actually. So you have graph given. All right, so the limit as x goes to -1 from the left, as x goes towards -1 from the left, right here, it's, I'm sorry, there's -1, -1 from the left, right there, it's going towards -3. As x goes to -1 from the right, it's also going towards -3. So as a whole, that limit is going towards -3. And f of -1 is also -3. All right, the limit as x goes towards 1 from the left. So there's 1 from the left, though it's going towards -3. That's why we have that. The limit as x goes to 1 from the right, why is it 2? That's the right of 1, it's going towards 2. So as a whole, the limit as x goes to 1 does not exist. F of 1 is 2, though, because when x is 1, it's clearly 2. The limit as x goes to 4 from the left, there's 4, the left of it, it's at -1. From the right of it's going towards 0, so that's why the limit doesn't exist, and f of 4 is 0. All right, last page, I think we're getting a visit there from Yogi the dog, you might hear him. Determine whether f of x is continuous at -1. Guys, you got to do some factoring in that first one. Get some, because you get 0 over 0, and that really doesn't tell you anything. But when you factor, you're just left with x. Plug -1 in, it's going towards -1. If you plug -1 in here, you get -5 over -2, which is 5/2. They don't equal each other, not continuous. Plug 6 in everywhere, you get 29, 29, 29. It is continuous. And then lastly, guys, the first one's not continuous because you have a hole and a vertical asymptote. Second one is not continuous because you have two vertical asymptotes. All right. Anything that I went over in this video is fair game question-wise on your quiz Friday. All right. This is Yak Math Videos signing out.